Problem that we're going to try to solve today would improve the identity. Tan x plus secant x equals cosine x over 1 minus sine x. All right. So, again, rule of thumb, we want to start with the most complicated side. Believe it or not, both sides look very complicated, but we want to choose the side that does not have any sines and cosines, and we want to work with that. So in this case, tan x, we know that's sine x over cosine x, right? Plus secant x is the same as 1 over cosine x. Now in this case, we want to find a common denominator. Well, we already have that common denominator, so we can write it as one fraction. That's cosine x on the bottom. So if that's cosine x, this would be sine x plus 1. Now, where do we go from here? Now, you notice on the right-hand side, we have cosine x over 1 minus sine x. We want to get to that destination. However, one of these steps in getting there, we want to multiply the top and bottom by the opposite factor, or what we call its conjugate. All right? So in this case, I multiply the top by sine x minus 1 and the bottom by sine x minus 1. What's going to end up happening here, I have something called FOIL method here. So we want to use the distributive property. So sine x times sine x is sine squared x. Negative 1 and positive 1, that's going to be negative 1. Now there's no middle term because I have here positive sine x here by the product of those two. Then here I have negative sine x here because the product of these two, positive sine x, negative sine x, that's going to give me 0. So I'm not going to have a middle term here. All right? Now at the bottom, that would still be cosine x parentheses sine x minus 1. All right? Now we're going to use our favorite Pythagorean identity, the most basic identity of them all, is cosine squared theta plus sine squared theta equals 1. Because that's going to help us transform this numerator. I have a sine squared x minus 1. Here's what I'm going to do. Well, if I switch this and put negative 1 plus sine squared x, well, where does that come from? Well, it comes from here. If I bring the positive 1 over as a negative and bring the cosine theta over, I'm going to end up getting here negative cosine squared x. The bottom will still be the same. Okay, so I'm going to have cosine x sine x minus 1. So now I have a factor of cosine at the bottom, canceling with one factor of cosine at the top. Here, I have the reverse order of what I need right here. So what I'm going to do is, when I rewrite, I'm going to go negative 1 plus sine x. Here I'm going to have negative cosine x here. And if I factor out a negative, that's basically going to give me 1 minus sine x, and a negative divided by negative is a positive, so indeed I'm going to have cosine x over 1 minus sine x. That's my destination.